This is the SNAP 2013 tutorial for the Bishop tab, which is a modified Bishop global stability. And the first box up here is a construction number, which you've already seen. It just sets which staging cut or construction cut we're on. And then here's a minimum depth. So you can eliminate very small failure circles, and the depth is whenever you draw a line from one point to another and then take that arc distance, the distance from the center of that to the arc, that is the minimum depth. And then you have a resolution, which a smaller number gives a little bit higher accuracy, but it's also lower speed. So I usually leave it at 1. And then layers can test for failure circles that go along a layer boundary between two soils. And then you can have the seismic case, and then tension cracks is it tests for vertical failures, and then it goes down into a circle. And of course, if you just have a center of a circle down here, it's vertical just for a little bit, you know, and then comes down. But this allows it to go vertical for a little bit further and then have a failure circle. And then you can show a plot, and I'll go ahead and show the plot first here. And the way to understand this plot is anything above the slope is your typical plot that's done for a lot of slope failure programs. Is that what it does is it tests all of the failure circles that have a center at a given point, and then takes the minimum factor of safety and plots that color. And so that's the meaning of everything above the slope. But I color everything below the slope in a similar manner, is at every point you look at all of the failure circles that go through that point, and then you take the minimum. And so then you can get a plot underneath the slope of what is the minimum factor of safety of any point under the slope. And then you can kind of see how things change. So if we add the layers, I'm going to click it and then watch if anything changes here. Okay, almost no change, maybe a little here on the edge. So there's really not any significant failure along the soil layer boundaries for this particular case. And the factor of safety really didn't change at all. And then we can look at the seismic case, and this is kind of interesting. A lot of people use the same failure circle for seismic as they do for the static case, but that is not always necessarily the case. In this case, it's pretty close to the same. But you can see it's a completely different map above the slope, and of course it's a lower factor of safety below. And it's fairly similar, I guess, in this case. Sometimes it can be different. And then tension cracks, because it doesn't test for tension cracks, so you won't see any failure circles below the top of this wall or below the top of this wall, if it's just testing for this case. But if I turn on the tension cracks, then it will test all of the circles around here. And so it leaves, there's a lot of places that are, it's taken into account that are missed if you don't use tension cracks. But you can see in this case it still is pretty much the same. Maybe if we change the minimum depth to like 0.5, come up with that, perhaps we would get a little bit slightly higher, but not too much. So see that in this case that wasn't that critical. I'll put it back to 2. And the resolution, we can maybe change it to 0.8 and see what that does. This will be much higher resolution. And it changed 1.57 to 1.58 actually went up there. Let's try 0.7. I wouldn't suggest changing that any lower than 0.5. Okay, now at this resolution it's able to pick up a few tension crack ones that are really small. And if you want to look at those, you might want to increase the resolution to 0.7. Of course, if we change the minimum depth to 3, those probably... Oh, 3 is still pretty small. We still get a failure circle right here. So these are some options that the modified bishop allows you to change so that you can look at different factors. And then the scale is for this color scale on the side. So if I hide the user interface, you can see it goes from 0 to 5. If you want to, in this case, maybe the highest is 1.57, and the lowest out here that maybe we consider would only be 3. So we can change this scale to 1.5 to 3. And then you can see that any place that's close to 1.5 is going to be, I'll turn this off, is going to be right in here. So you can see this is the most dangerous part of the slope. And then it just changes the factor of safety to 1.5 to 3. But usually I leave it at the default 0 to 5. And you can change to different construction cuts. So if I want to change to 7, that'll automatically change the construction cut and show the factor of safety for this. And here we've got this reduces to 1.66, even though the global one. And you'll see it'll plot a failure circle for each wall and for the slope. But if a wall that means it has to fail above the wall and below the wall, above the wall and below the wall, and then the minimum for the entire slope. But sometimes you'll only see 1, or you'll only see 2 instead of 3, and that's because 2 of them are actually the same. They overlap at exactly the same point. So even though it looks like there's only 2 here, there's actually 3. This one is the minimum for the slope, and it's also the minimum for this wall, but it's not the minimum for the one that fails above this wall and below this wall. And that should cover about everything you need to know for the bishop test.